Hmm. Start.
Good morning, all of you. Uh, Today we shall discuss the last topic of general physiology, which is about briefly. I will speak about apoptosis, and also last about a couple of classes ago, I had just introduced the concept of positive feedback mechanisms and feed forward mechanisms. So let us continue from there, and we will discuss very briefly about the positive and the negative feedback mechanisms. If you remember in the class which I had taken homeostasis, I had said that maintenance of a constant internal environment is essential for the normal functioning of the cell. In that, to maintain a constant internal environment, two processes which help us are the feedback mechanisms and the feed forward mechanisms. In this feedback mechanisms, there are two subsections. One is a positive feedback mechanism and the other is the negative feedback mechanism. Now, what do we mean by negative feedback mechanisms and positive feedback mechanisms? Now, as the word suggests, feedback, that is giving an information back to the cell about the status of the functioning and the extent of the disturbance which is existing in the cell. To put it more simply, let us say that the normal blood pressure has to be around 120 by 80 mmHg. Now, for some reason, if the blood pressure increases from 120 systolic or 80 diastolic to it goes up to 160, 170 by 100. Now, this change in the blood pressure from a normal 120 by 80 to 160 by 70 is caused by certain factors, and that factor is a stimuli. Maybe the stimuli, maybe the stress, maybe the physical stress. You have done exercises and the blood pressure has gone up, or you have suddenly got angry and your blood pressure has shot up. So, whatever the stimulus may be, this external stimulus, which is in the form of some external environment or some factor triggering you to get angry, or some internal factor where you have done a very heavy bout of exercise and that has raised your blood pressure. This external factor or internal factor is changing the blood pressure from 120 normal to 160 by 100, 160 by 120 by 80 to 160 by 100. Now, when this changes occur, it is a deviation or moving away from the normal, and the body will try to first detect that there is a disturbance or a change in the blood pressure. So, this change in the blood pressure should be brought back to normal. So, immediately signals are sent from the various regions of the body to the centers, that is the center which is controlling the blood pressure in the brain, and giving a signal so that the blood pressure mechanisms are triggered, and those mechanisms which are triggered should bring the blood pressure back to normal. So when the blood pressure is being brought back to normal, this mechanism is negating or cutting off the extra factor, cutting off the stimuli which has caused the blood pressure to rise. So it becomes a negative feedback mechanisms, where the mechanisms which are triggered because of this external stimuli act exactly opposite to the stimulus which is acting in that particular direction. That means the stimulus is causing the body to behave in one way. The mechanisms which are activated are acting in a direction opposite to that particular stimuli. So it is a negative feedback mechanism. Then the next question comes is, what is a positive feedback mechanism? A positive feedback mechanisms are mechanisms where the body's regulatory systems or the control systems are working in the same direction, in the direction in which the stimuli is acting. Say for example, now we'll explain with the help of an examples. Say for example, your bleeding tendency. When we get hurt or when some bleeding occurs in any part of the body because of trauma, you will find that the bleeding comes or stops after a few seconds or a few minutes. The normal homeostasis says that the blood should remain within the blood vessels. The blood should not move out of the blood vessels. It should remain in the circulatory system and it should remain in the fluid mechanism. But once there is any injury to the blood vessel, this injury is triggering certain mechanisms where because of this injury there is a change or a break in the blood vascular epithelium or the endothelium. This endothelium are nothing but coming in contact with the blood, the clotting factors in the blood. A clotting factors in the blood is stimulated or is triggered and causes the blood to clot, so that the arrest of bleeding or the stoppage of bleeding takes place. Now imagine that in a very small fragment, a clotting factor is stimulating. This clotting factor is now triggering or activating some more quantity of clotting factors. So the amount of clotting factors present at the site of injury increase. As the quantity of the clotting factors goes on increasing at the site of the injury, the clot becomes more and more and bigger in size, till a big clot is formed sufficient enough to close the hole or the rent in the damaged vessel wall, and the bleeding comes to an end. This is one example of a positive feedback mechanisms, where because of this a small injury stimulating or triggering or activating the clotting mechanism. The clotting mechanism runs into a cascade where a little bit of clotting factors triggers some more amount of clotting factors, so that more clot is formed. Once a small size of a clot is formed, it triggers more and more clotting factors or activates more and more of the clotting factors, so that ultimately a big clot is formed which is sufficient to stop the bleeding. So this is an example of a positive feedback mechanism where the injury is stimulating the clotting factors. Subsequent processes are moving in the same direction to cause more and more activation of clotting factors, so that ultimately a big clot is formed. This is an example of a positive feedback mechanism. Another example of a positive feedback mechanism which we can give you is the two examples can be given here which are concerned. One is the physiological processes involved during childbirth. We know that at the end of pregnancy or a term or gestation, say around at 36, 37, 38 weeks, the uterine contraction starts, that is the uterus begins to contract. Initially, before the delivery, which takes place say 24 hours before, the uterine contractions are very mild. Slowly, once the contraction begins, the intensity of the contractions and the frequency of the contractions increase. Ultimately, the contractions become so intense and so frequent that the uterus starts contracting freely, more frequently, and tries to deliver or expel the fetus out, and a delivery takes place, the childbirth takes place. Now, what is this mechanism? This mechanism is again an example of a positive feedback mechanism. How is this an example of a positive feedback mechanism? Now, when the uterus has reached a full term, that means 36 or 37 weeks of gestation, the uterus is getting stretched. In the subsequent classes, you will learn that uterus in a non-pregnant female is just a pelvic organ. That means the uterus is so small that it remains within the pelvic cavity. Once conception takes place and the pregnancy starts and the pregnancy progresses, from the first trimester, that is from the first 3 months, to the next second trimester, that is the to the third to the sixth month, and in the third trimester, when it reaches term, the size of the uterus gradually increases, and during this 36-37 weeks, which was a pelvic organ becomes a abdominal organ, and at term the size of the uterus reaches ultimately the umbilicus or up to the episternum, that is the epigastric region. Now, at this point of time, the uterus has stretched to a maximum. We know that uterus is nothing but a smooth muscle. Stretching up of the smooth muscle will trigger certain contractions of the smooth muscle. At the same time, there is a hormone which is released, which is called as oxytocin. This oxytocin will act on the uterus and make the contractions more and more powerful. So once the contractions, which are mild initially, in the next few hours become more frequent and more intense, they try to push the fetus towards the outlet, and as the fetus descends downwards, it causes more and more stretch of the outlet. This stretching of the outlet of the birth canal will stimulate more and more nerves, so more and more impulses will reach the pituitary gland, posterior pituitary gland, to release more and more of oxytocin. As more oxytocin is released, more oxytocin acts on the uterine smooth muscle, causes the contractions to become more and more powerful and more frequent. So this process goes on and on. So as the intensity and the frequency of contraction increases, the uterus contracts to push the fetus out. As the fetus descends out of the birth canal, it stimulates more and more impulses from the birth canal to go to the pituitary to release more and more oxytocin. So ultimately what happens is, there is such a strong intense uterine contractions, and the delivery of the child takes place. So here what is happening, the stimulus is nothing but stretching of the uterine smooth muscle, triggering a mild contraction, because muscle is an elastic tissue and an excitable tissue. If it is stretching beyond a limit, it initiates a contraction. So whatever stretches has to contract like a rubber band. It follows the principle of elasticity. So beyond a stretch, it contracts. When it contracts, it pushes the fetus down. It stimulates the posterior pituitary to release more and more of oxytocin, and the contraction goes on, increases. So this ultimately causes the fetus to deliver, and is an example of positive feedback mechanism. वैसे चलते the same example can be continued to explain another mechanism occurring in the body, which is a positive feedback mechanism, is the milk ejection reflex. This is another example of a positive feedback mechanism. Here in this example, you will see that once the childbirth has taken place, in the next couple of hours after the child is born, the feeding of the newborn or the infant takes place. Now, as the mother puts the child onto the breast, the suckling of the nipple will stimulate the ejection of milk. This is another example of positive feedback mechanism. And how this reflex work is, the mother puts the infant on the breast. The suckling of the nipple will stimulate the sensory nerves. Stimulation of the sensory nerves will release again oxytocin. The oxytocin will act on the breast tissue, will act on the gland, and the glands will contract and expel the milk, and thus the milk is ejected. So more the suckling of the nipple, the more is the oxytocin will be more oxytocin released from the posterior pituitary, and more will be the contractions of the lactoferous glands to cause the ejection of the milk. So this is another example of a positive feedback mechanism. Similarly, we have got examples in the body of negative feedback mechanisms. Another example for positive feedback mechanism you can add is for the functioning of the hormones. A stimulus causes the release of the hormone from the gland. Once the the higher gland releases the hormone, more and more of it is produced. Some glands may act as, some hormones may work in a positive feedback mechanism, some may work in a negative feedback mechanism. This we will discuss individually when we go into endocrine, when we deal with endocrine physiology. Now, for coming back to the negative feedback mechanism, in the negative feedback mechanism, the functioning of the body or the mechanisms which are responding to the stimulus act exactly in the opposite direction of the stimulus. Say for example, now when a person is lying down, after lying down, when you suddenly get up, you will find that there is a fall in the blood pressure. Now the body detects that as soon as a person has got or stood up from a lying down position, there is a fall in the blood pressure. The body detects this decrease in the blood pressure, stimulates the vasomotor center and the cardiac center to bring the blood pressure back to normal. How does it happen? Say for example, you have been lying down in a lying down position. Suddenly you stand up. When you stand up, there is again sudden, because of the gravitational pull, the venous return drops. When all the blood in the body is moving towards the downward direction, toward the lower limbs, the blood coming back to the heart is less. That means the venous return is less. When the venous return is less, the blood returning to the heart is less. When the blood going back to the heart is reduced, the blood pressure falls. This decrease in the blood pressure is detected by the receptors in the body, that the blood pressure, instead of being normal at 120 by 80, has come down to around 100 by 70 or 90 by 60, and this drop or fall in the blood pressure is detected by the baroreceptors, which are the receptors nothing but which detect the pressure of the blood pressure in the heart, in the body, and they get immediately stimulated and they increase the force of contraction of the heart so that the blood pressure comes back to normal. If this mechanism does not comes back to normal, suddenly you will find that there is a giddiness or there is a blackening in front of the eyes, which is known as sudden blackouts, or in medical it is called as a vasovagal syncopes. So here, whenever there is a change in the blood pressure, it is detected by the baroreceptors. The baroreceptor sees to it that the blood pressure is restored back. So this is a negative feedback mechanism where sudden change of posture is causing the blood pressure to drop, whereas the body system is working in a direction to negate the drop in the blood pressure so that it is brought back to normal. See, another example of a negative feedback mechanism working in the body is the body temperature. We know that whenever there is a change in the body temperature, it disturbs the normal metabolic activity, and this disturbance in the normal metabolic activity will alter the functioning, where the optimal temperature at which the enzymatic reactions takes place will not be happening, so it will result to a metabolic breakdown. So it is very essential that the blood pressure remains constant at 98.6 degrees Fahrenheit. Now, whenever there is an increase in the body temperature, that means Medically, when you have fever, technically it is called as fever. So whenever there is a fever in the body, the thermoreceptors in the body will detect that the body temperature is above than what is normally set for the body. Say for example, at 101 degrees centigrade, 101 degrees Fahrenheit, the normal blood pressure should be 98.6 degrees Fahrenheit. The temperature now is 100 degrees or 101 degrees Fahrenheit. The body detects that the temperature is above the set point center. Immediately it triggers certain mechanisms in the body so that the body temperature comes back to normal. And how does it do that? It does by causing profuse sweating. So whenever there is a fever in the body, you will see to that after some time you will begin to sweat. Once the sweating takes place, the body temperature comes back to normal. Or if it doesn't comes back to normal, you take some simple paracetamol tablet or an antipyretic medication. This antipyretic medication will act by provoking certain sweating in the body. So once the sweating occurs, that means that heat is lost from the body. So what was from above 98.6 to 101 degrees Fahrenheit is lost, that heat is lost from the body in terms of sweating, and the body temperature comes back to normal. So this is again an example of a negative feedback mechanism where the stimulus has caused the body temperature to rise, but the body mechanisms are stimulated and acting in a direction exactly opposite to rise to counter it so that the body temperature comes back to normal. Similarly, whenever there is a fall in the blood pressure, that is, if your suddenly body temperature falls, immediately you will find that you begin to shiver or there is a chills. When there is a chill or shivering, what is happening? The muscles are contracting. When the muscles are contracting, heat is produced in the body because every muscle contracts. Shivering is nothing but contractions of the skeletal muscle. This contractions of the skeletal muscle is producing heat. Once this heat is produced in the body temperature rises. So what was subnormal temperature, now because of the shivering and chills, there is a heat generated and the body temperature comes back to normal. So this is about a negative feedback mechanisms where the mechanism is trying to restore the body temperature back to normal in either ways. Whenever there is an increase or there is a fever, it sees to it that the body temperature comes down, or whenever there is a hypothermia or chills, it brings it back above from less than 98.6 back to normal. The last example and other is the feed forward mechanism. What is feed forward mechanism? Now feed forward mechanism is an anticipatory mechanism where the body tries to correct a damage which is likely to occur. Now to explain in a practical example, suppose you are running on a plain ground. Suddenly you find that while you are running, there is a ditch where you can, or there is a step or a stone where if you accidentally put your step on it, you will fall down. Now just see the condition. You are running, suddenly you find a ditch there. To prevent a fall into the ditch, you just increase the direction or the distance of your next step so that your next step lands ahead of the ditch and you prevent a fall. Similarly, while playing for some sports, say for example you are playing basketball. As you are playing basketball, suddenly you find that if an opponent is in front of you, to prevent colliding with him, the body takes a turn or adjusts itself in such a way that you prevent the collision with the opposite player, either when you are playing basketball, football or any other game. So what is this? This is not a planned activity, but a body is stimulating a mechanism whereby the damage to the body is prevented in anticipation that if you don't take this step, you may collide or you may fall down. This is called as a feed-forward inhibition, where normally where you would have put your step, you suddenly the brain subconsciously realizes that there is a danger ahead. So to overcome the danger, instantly the central nervous system acts and make you to step little ahead, so that in example you don't fall down, or when in a game you suddenly take a turn away from the opponent in order to prevent a collision. So this is an example of a feed-forward mechanism where actually nothing has happened, but in anticipation of a damage happening, corrective measures are taken by the body. So this is about the feedback mechanisms and the feed-forward mechanisms. Now briefly I will tell you about one small topic, which is apoptosis. Apoptosis is nothing but actually it is a part of aging, and we will discuss it in detail when we discuss about the aging mechanisms or the processes of aging in integrated physiology at the last. But now what is apoptosis? Apoptosis is nothing but a programmed cell death. We know that the cells, after working for some time, exhaust all its nutritive material. They may be replaced constantly, but despite the nutritive materials being replaced, there is an accumulation of certain toxic material, or which is known as reactive proteins or reactive substances, ROS. So these reactive species or reactive substances or oxidants, oxidative substances in the cell gets accumulated, and when they get accumulated to an extent that it cannot be removed from the body, it causes it cannot be removed from the cell or cannot metabolized by the cellular substances, it results in death of the cell, and this is known as a programmed cell death. It is also called as falling off of the cell or dropping off of the cell. Now, in fact, how is this programmed cell death or apoptosis different from necrosis? Necrosis and apoptosis are one and the same, but apoptosis is normally occurring, is good for the body. Necrosis is not so good for the body, because necrosis happens only when there is an injury or a damage or a foreign body invasion. So necrosis is pathological when there is a damage or when there is a bacterial attack happening, some of the cells get damaged, or when there is less supply of oxygen to some part of the body. Because of the lack of blood supply, the tissues get damaged and ultimately they get necrosed and they are phagocytized and removed from the body. The damaged tissue is removed. That is necrosis. On the other hand, apoptosis is programmed. It is programmed in such a way that this cell will function normally for a given particular period of time, after which it will stop functioning. Once it stops functioning, it is removed from the body, and that is known as a programmed cell death, falling off or dropping off, or apoptosis. Now, one of the features of this apoptosis is that it is coordinated, it is a coordinated function, and it is an internally planned death. So whenever some cells are going to die or stop functioning, the body sees to it that the damaged cells are replaced in an orderly manner and in a timely manner, so that the function of the apoptotized cell is taken up by the newly formed cell. So it is nothing but a coordinated and an internally planned cell death. Now, the other feature of this apoptosis is that it has a genetic control. There is a genes which is controlling the timing of the cell death and the extent of the cell death, and once these genes or these oncogenes are stimulated, then the cell death or the apoptosis is triggered. Now, what are the examples of apoptosis or programmed cell death? One, during development, certain neurons are decayed. So neuronal decay during the embryonic development or during the first few months after birth is an example of apoptosis. Then we have certain degeneration of tissues taking place in the fetal development, that is the web spaces in the fingers not getting developed is another example of degeneration of tissues in the fetal development, during fetal development. Then some cells like eosinophils and other blood cells also undergo apoptosis. So these are the few examples few examples of apoptosis which is happening in the body. Now what does apoptosis does? Now when there is an apoptosis taking place, it causes the removal of the unwanted cells in the body. So what cells are not wanted are removed from the body. So unwanted cells are removed, degenerated cells from the body are removed, harmful cells are removed, and some self-reactive cells. What are self-reactive cells? Certain cells have the capability of multiplying on its own, and these are known as self-reactive cells. So because of apoptosis, the advantages in the body are the unwanted cells, the degenerated cells, the harmful cells, and the self-reactive cells are removed from the body. Now there are two ways of it. As long as the apoptosis is happening normally, it is useful to the body. Any decrease in the apoptosis or increase in the apoptosis, both are harmful to the body. For example, the apoptosis ideally should occur at certain fixed rate or a particular level at a particular manner. If this rate of apoptosis is decreased, that means the programmed cell death is not occurring, or the cells are not removed, or in some human being, in some body, there is a decreased apoptosis. That means that there is an accumulation of normal cells. This can result in malignancy. So broadly, just understand and remember now that a decreased apoptosis is a prelude for malignancy or for cancer occurring in the body, or it can also result in autoimmune disorders. Now, what is the mechanism by which this apoptosis takes place? We said that apoptosis is a programmed cell death. How does this programmed cell death occur? Now, this programmed cell death occurs by the activation of certain proteins in the cystine proteases in the body, and those are known as caspases. So activation of these enzymes known as caspases will trigger the apoptosis. Normally, these caspases are inactive within the cell. Once they become activate, they trigger the cell death or they trigger apoptosis. Now the next question is, what are the factors which triggers this conversion of these inactive forms to active forms? We know that programmed cell death occurs. It is a perfectly timed program. It is under genetic control. Once it is under genetic control, it triggers the enzyme, certain proteases. Among them, one is caspases. Once this caspases gets activated, this caspases will cause the conversion from inactive form to active form. Once this converts inactive form to active form, how does this conversion from inactive form to active form takes place? This is done by two stimuli. One is an internal stimuli and the other is the external stimuli. What do you mean by internal stimuli? Internal stimuli means the mechanisms which are taking part within the body or within the cell are the internal stimuli. Cells or factors which are triggering this conversion from inactive form to active form outside the cell are external stimuli. So we have got external stimuli or an internal stimuli. These stimuli will convert the inactive caspases to active caspases. Once these active caspases are becoming active, they cause the destruction of the cells. Now these factors which are stimuli, that is the intracellular factors, are nothing but stimuli which stimulate certain receptors which are present inside the cell. Hence they are known as intracellular stimuli. Stimuli which are triggering the conversion from inactive form to active form. If they are stimulating the receptors present outside the cell on the cell membrane, then they are the external factors. So external stimuli and the internal stimuli. Then next question comes, what are the receptors which are triggered when an internal stimuli takes place? The internal stimuli mainly causes the activation of a receptors which are known as tumor necrosis factors. So either the tumor necrosis factor which is present inside the cell on the cell organelles will get activated, or excess heat inside the body, or radiation inside the cell, or hypoxia inside the cell. Any one of these factors can trigger the internal stimuli. Similarly, on the outside of the cell, there are certain factors like the normal hormones. We know that for the normal functioning, there are certain hormones which are required. These hormones come and bind on the cell membrane. Once this binding takes place, the normal functioning of the cell takes place. Similarly, there are certain proteins which are known as G proteins, and these G proteins are responsible for the normal functioning of the cell. Now, if there is a lack of binding of these hormones or these G proteins on the cell, the survival of the cell does not take place, or the survival of the cell or the functioning of the cell itself becomes questionable, leading to the triggering of the conversion of inactive caspases to active caspases. So these are the external stimuli which can trigger the apoptosis. Now, there are other factors also which are responsible for, which are a part of this. That is, what are the factors which are genetically regulating this apoptosis? What are the factors which are regulating this apoptosis? What are the steps involved in apoptosis, and what are the processes which are involved? We will discuss at the end of the whole complete physiology, because it involves understanding of minute processes and minute physiological mechanisms. So at this point of time, it is enough here to understand first how does it take place, what are the stimuli, what is external stimuli, what is internal stimuli, and lastly what are the applied aspects. At this point of time, you should understand that whenever there is a decreased apoptosis taking place, this decreased apoptosis will lead to certain cancers and autoimmune diseases. On the other hand, if there is an increase in the programmed cell death, or increased activity of apoptosis are taking place, or if there is increased cell death, it may result in certain neurodegenerative disorders. Like, the neurons normally have to function for a certain specific period of time. If these neurons, because of apoptosis, starts getting destroyed or destroyed, their functioning gets altered. When their functioning gets altered, it results in neurodegenerative disorders. So one of the examples of an increased apoptosis causing neurodegenerative disorders is Alzheimer's disease. So what is Alzheimer's disease? Alzheimer's disease is nothing but forgetfulness at the elderly age group. Normally, we find that people who are in the elderly age group begin forgetting things. Sometimes it is to the so extreme end that the person, when he walks out of the house, say an 80-year-old man walking out of the house, will not remember the road to come back to the house. Or to some extent, it is to such an extent that the person may have had his lunch, but he will not remember that he had his food and may start eating again. So this is because there is a neuronal degeneration in the lobe hippocampus, where the person is not able to remember this. So why is this forgetfulness happening? One of the theories attributed to it is that there is a neuronal degeneration taking place, and this neuronal degeneration is because of apoptosis happening, as a result of which the person forgets things or does not remember. This is an example. This is called as Alzheimer's disease. So one is Alzheimer's disease, then there is a Huntington's disease, Parkinson's. Some of these, so these diseases are attributed to increased apoptosis. With this, we stop here, and I hope with this we complete the general physiology. If you have any doubts, or if you want any of the topic which we have covered in last 1 month in general physiology to be clarified, please send those list of your doubts to the mail, and on Saturday between 10 to 11 a.m. one of the faculty member will be present here, and point wise or in orderly way they will clarify your doubts. Thank you one and all. Have a nice day.